All right, so our objective for today, I can simplify exponential expressions using the division properties of exponent. Let's read together. 1, 2, 3. I can simplify exponential expressions using the division properties of exponent. So what concept are we still on? Tell you what concept we're still on. That's why we don't need a Fourier model today, because we already know what exponential expressions are, right? Everybody got that question correct in the part A, right? Number 3? Good. You memorized the definition really well. Very good. The objective goes on the bottom left of your notes, right? And I said not to make one of these, didn't I? Okay, good. All right. So, what are exponential expressions? Once again, we don't need this. You already have it. A numerical variable expression raised to a power greater than 1. Pretty good? Some of you put numbers with exponents.
I put that.
Okay. So pretty close, but make sure you know your definitions, yes? And when I'm asking for definition, it doesn't mean that I want examples or non-examples. I just want the definition, okay? Steps. Don't copy these. We'll copy these tomorrow because I want us to get to the practice, but look at the steps. We're going to identify the exponential expression if it's a quotient of powers or power of quotients. Pretty much the same steps from multiplication that we did last week. Use the appropriate property to compute and simplify. Do they look familiar? Yeah, right? Just the properties are different. Quotient of powers, power of quotients. Today we're going to focus on quotient of powers. So, copy that, please. Instead of where you write your Fourier model, write quotient of powers property. Quotient of powers property. Instead of writing the box, you wrote quotient of powers property. Well, zoom out. Here we go. Example Q. Write this down, please. 3 to the 6th power divided by or over 3 to the 4th power. Why am I saying divided by? Because this week we're looking at what? Division properties. Okay. Underneath that, copy this. X to the 10th power divided by or over x to the 7th. And underneath that, I want you to write x to the 5th power divided by y to the 4th power. And I'm going to draw an arrow like this for each one of these. Okay? All right. Writing utensils down, look up to the screen. Once again, this is where I showed you. Your noodle does all the work. Make sure you come up with a good definition. Look up, please. So here it goes. Talk over your neighbor. See if you can come up with the definition or a rule. All right, copy that, please. And underneath here, I'm going to get my asterisk and a heart. Oh, ready? I'll just wait for you guys. Copy that, please. All right, so let's see. So this week we're working on what? Division. So let's start our definition. Starts with when what? When dividing. Very good. Dividing. What are we dividing? What are these called? Bam. Exponential expressions. That what? Tell your neighbor, please. That what? Priscilla, that have what? That have the same base, comma. What do we do, everyone? Subtract the exponents. And you guys are pretty good. Oh, I forgot. 10 cubed. Yes. Man, that deserves extra credit. Yes, sir.
Another question, what if like the number on the voice the number on the top can have a bigger exponent?
No?
And then how would you do it if the exponent is...
We'll cover that right now. Yeah. Look up, guys. The question was, is the number on the numerator or on top always going to have the greater exponent? No. Right now I showed you like that so you can see the rule, and right now we're going to get into the ones that don't have the exponent greater on the numerator. All right. Now, why does this work? Look up, please. Pens down or writing utensils down really quick. Look up. Let me show you. 3 to the 6. 3 to the 6 is 3 times 3 times 3 times 3 times 3 times 3. Do you agree with that? Look at the denominator of that one is 3 to the 4th, which is 3 times 3 times 3 times 3. Do you agree with that? So now, let's look at one step at a time. What is 3 divided by 3?
1.
What's 3 divided by 3?
1.
Therefore, all of these make a giant 1. So what is 1 times 3 times 3? 3 to the second, or 9. Did you see that? Copy that, please, and do the same with the x's and see if it works. And this is what we call factored form. So like that, in case you guys have doubts of your answer, I tell the kids every year, when in doubt, factor out. See what I did there? Could be a rapper. In Christmas, I do rap. Do you guys know that?
Can you rap for us?
Yeah. We wrap tamales, presents. Cheese tamales. You guys tried cheese tamales? No? They're good. Did it work also with the x's? Yes, right? Giant ones all the way through, and then you should be left with x to the third. I'm going to leave that up on my screen, and while some of you finish copying, and on your screen, I'm going to forward your screen so you can do problems 1A and B. Copy those to your paper. Do those on your paper. Copy that. All right, so I'm going to advance your screen. It's going to be blank. I want you to send me the answer for 1B. 1B. There it is. Lock your toolbar. Send me the answer for 1B. All right, so let me go over this one so that hopefully we can clear up mistakes. Look up to the screen, writing utensils down. So this one. Same base? Yes, it's 2. 9 minus 7, that is 2. 2 to the second. Are we there? If I'm asking you to simplify to lowest terms, then this is 4. Next, look at this one. Y to the first and y to the fourth. Are they the same base? Yes. 1 minus 4 becomes negative 3. Make sure you write it out if you're making mistakes with the exponents. Okay, copy this next one, example C, 1C. Let's see how we do with this one. Let me zoom in so you can see. Who sees Then in the denominator, yes, sir. Who sees the denominator has more stuff to do, right? So let's focus on that. So what do we do here in the denominator first? We simplify, which means we multiply the 5 and the 2. So this becomes m to the 10th, and this is n to the 1st. All right. Then we bring these over, m to the 5th, n to the 4th. And now that we have that simplified, let's start one base at a time. Are these the same bases? Yes, that's m. So what happens to the exponents? We subtract. 5 minus 10 is negative 5. Are these the same base? Yes. And then we do 4 minus 1, which is 3, and we're done. Home play for tonight is the play sheet. I have it over here in the front, 7-2. And you're only doing problems numbers 1 through 12 only. Okay, so on your way out, make sure you log out of Nearpod, log out of the internet, and close all windows. Once you're done, here's your home play. Enjoy your home play, guys. Have a good one. See you guys tomorrow. Oh, don't forget to get those party signs, please, and correct it. Bye.